Hi, we're presenting today's system of linear equation, the team of Fernando, Alessandra, Sofia, and Natalia.
A linear equation with two unknowns is an algebraic equality of the type ax plus by equals c, where x and y are the unknowns and a, b, and c are known numbers. The solution of a linear equation with two unknowns is a pair of values, x and y, that make the equality true. What does it mean to find the solution of a system of linear equation graphically? It means that by finding the solution of the two unknowns of the linear equations in question, they respectively the point in the Cartesian plane where the two lines intersect.
Types of solutions. System of linear equation. They are the same lines, so every point on the solution is a solution. So there are infinite solutions. That's why we only have one line in the graph. If we got two lines in the graph and they're like crossing, that would mean there is only one solution because the lines intersect at one point. This point is the only solution to the system. But if we have parallel lines, that would mean no solution because the lines are parallel. They never intersect, so there are no actual solutions.
I am going to explain the substitution method. This method works by substituting the value of one variable from one equation in the other equation. This is my example. We have two equations. Equation 1, which is 2x minus 3y equals minus 11, and equation 2, which is x plus y equals 7. There are some steps we need to follow. Step 1 is to isolate the unknown variables in one case of the two equations. Mostly the easiest one. In this case, I'm going to isolate x. So x equals 7 minus y. Because here it's multiplying, and so I pass it subtracting since it's the opposite. Step number 2 is to substitute the isolated unknown into the other equation. I'm going to substitute the value of x in the equation 2x minus 3y equals minus 11. So, from the equation 2x minus 3y equal minus 11, it's going to become 2 multiplied by 7 minus y minus 3y equals minus 11. So I substitute the value of x, which is 7 minus y, for the x in the second equation. Step number 3 is to solve the equation and obtain the value of the unknown variable. We have to solve this equation by using PEMDAS until we get the answer. So first we need to multiply the 2 and the 7, which is 14, and the 2 and the minus y, which is 2 minus 2y, and we leave the other things of the equation. We continue to simplify it, so we can simplify the y variable by putting it like minus 5y equals minus 11. So now we pass the 14 to the other side, and it's minus 5y equals minus 25 because we passed the 14 to the other side. Subtracted. Now, since we have to leave the y alone, we pass dividing the minus 5, and it's minus 25 divided by minus 5, and y equals 5. Step number 4 is to substitute the obtained value, which is y, in the other equation for us to get the value of the other unknown variable. So in the first equation that I had, that was x equals 7 minus y, now I substitute the value of y that I know is 5 in this equation. So now it is x equals 7 minus y, and y is 5. So we know that x means 2. And that's how I get my two answers. And lastly, To prove that my theory is right, I can substitute the values of x and y in the equations, so to see if it gives me the value it says. So in the first equation, I substitute x with 2 because x equals 2. So it's 2 times 2 minus 3 and y is 5. And it's give me minus 11. And multiplying this, 2 times 2 is 4 and minus 3 times 5 is minus 15. And I can prove that it gives me minus 11. This one is correct. Now for the second one, I have that my equation is x plus y equals 7. So x is 2, y equals 5, and I can prove that it gives me 7. And that's how I know I was right.
Reduction. The method of reduction consists in performing arithmetic operations between equations to obtain equivalent equations with less unknowns. Okay, for example, if we wanted to do an equation of x plus 2y equals 9 and 3x minus y equals 20, we would first have to multiply this first whole equation by the coefficient 3 of x because we're wanting to reduce x. So this equation would transform to minus 3. Why minus 3 times the whole equation? Because we want to reduce it. So we want to do something at the very end of this reduction of x, that it would be adding the two equations. So we have 0 x left. So we would have to have minus 3x plus 2y equals 9, which that would end up with minus 3 minus 6y equals minus 27. And we would add that to the 3x, I didn't write x nor y, minus y equals to 20. So that when we add that, we will have 0x, that is what we want because we're reducing x, minus 7y equals to minus 7. So we now want to isolate the variable y, so we will have minus 7y equals to minus 7, and it's y equals to minus 7 over minus 7, which that gives us 1. So y equals to 1. Now, if we want our x, we have to reduce y. How are we going to do this? We can do this both. We can have two options. First option would be 3x minus y equals 20. And we will have to replace the y for the one that we already have. That is this one. So 3x minus 1 equals 20. We have to isolate our variable x so we can get x. So that would give us 3x equals to 20 plus 1. And we still don't have our variable x isolated, so we would have x equals to 21 of the 20 plus 1 divided by 3. With that, we have 7. So our x equals to 7. But if we don't get y, or if we haven't done that yet, we can actually do the same we did with y while reducing x, but this time reducing y. So we have x plus 2 equals 9, and 3x minus y equals 20. And what do we do? Now we multiply this by the coefficient of 2. So we will have 2 by the whole equation, 3x minus y equals 20. Now, this would give us 6x minus 2y equals 40. Now we can actually do the operation, which would be x plus 2y equals 9 plus 6x minus 2y equals 40, which that would give us 7x plus 0y equals to 49. Now that we have 0x, we can actually eliminate it, and we have 7x equals to 49, but we want to isolate our variable x, so we have x equals to 49 over 7, which that gives us 7. So there are our intersection points, that it's 7, 1. So that's it. Thanks for your attention.
Next is the Cramer's method. The Cramer's method solves systems of linear equations by dividing the values of two determinants. The number of equations is equal to the number of unknowns. The determinant of the matrix of the coefficients is different from 0. Such systems are called Cramer systems.
Fully, we first need to understand what is a matrix. A matrix is a two-dimensional arrangement of numbers. It is represented by a capital letter A and B and its elements with the same letter in lowercase a and b, with a double subscript where the first indicates the row and the second the column to which it belongs. The dimension of a matrix. The number of rows and columns in a matrix is called the dimension of a matrix. Thus, a matrix of dimension m times n is a matrix that has m rows and n columns. I will show you how to solve a linear equation following the Cramer's method. We first need to get our main determinant. So we arrange the coefficients this way as they appear on the problem, and we then multiply diagonally and subtract the products. So it would be 2 times 2 minus 3 times 3. 2 times 2, this is 4, minus 3 times 3, which is 9. 4 minus 9, it gives us minus 5. Our main determinant is minus 5. Then we need to get the determinants for x and y. Our determinant for x will be replacing the values of the x columns by the numbers of the equality. So instead of 2 and 3, we will put 1 and 4. And for the y column, it will stay the same. And as we did for the main determinant, multiply and then subtract. 1 times 2 minus 4 times 3. 1 times 2 is 2. 4 times 3 is 12. This gives us 2 minus 12 minus 10. Our determinant for x is minus 10. The y determinant is pretty much the same, just instead of the replacement of the x column, it is for the y column. So instead of 3 and 2, it will be 1 and 4. You already know it. Multiply and then subtract. 2 times 4 minus 3 times 1. 8, so 8 and minus 3, this gives us 5. Our y determinant is 5. And now At last, we need to get x and y, which is pretty simple. We just need to divide their determinants by the main determinant. So we just substitute the values. The determinant for x is minus 10. The main determinant is minus 5. This gives us that x is equal to 2 and y, determinant for y divided by our main determinant, and determinant for y, it is 5, and our main determinant is minus 5, so it gives us y equals -1. And this is how you easily solve a linear equation following the Cramer's method.
So now that we saw the one with two variables, now we're gonna see it with three variables. When calculating the determinant of a matrix with three variables, it's the same as with two, but with more procedure. We need to find a, bx, cy, tz, and to calculate the variables x, y, and z. So here is an example that I'm going to show you how to do it. So first, like I said, we need to calculate all of the a and the bx, but first let's just focus on a. So first, we're going to write only the coefficients with brackets. So these ones. This is a 1, the -6, the 5, the -9, and the -4. So we're going to put a is equal to -2, -3, 6, and 8, 1, -6, and 5, -9, and -4, and with brackets. Then outside to my bracket to the right, which is right here, we're going to write the first two coefficients that we wrote previously. So it will be 2, -3, 8, 1, 5, and -9. Now the way of multiplying it will be, you're going to multiply diagonally these numbers minus these numbers. It would be something like that. Now it will be multiplying this one plus this one, multiplying this one, this one, this one, plus this one, this one, this one, plus this one, this one, this one, minus this one, this one, this one, minus multiply this one, this one, this one, plus this one, this one, this one. So it's a long process, but let's do it. So it will be 2 times 1 times -4, these, plus the -3, -6, and 5, plus once again the 6. Also be very careful with the signs, if it's positive or negative, because it could affect your result. Now in here, once you're done with all the red ones per se, you're going to subtract this by the blue ones. So then it's 5, 1, 6 plus 9 minus 6 times 2, and then times -4, 8, and -3. So all of this, you're going to put it on your calculator, also very keeping in mind the signs and all that. And it would be minus 350 minus 234, which is equal to minus 584. So your A will be minus 584. So that's A. Like I said, we need to calculate A, B, X, C, Y, D, C, and X, Y, and Z. So A is finished. Now to calculate BX, the order of the coefficients will change, so you don't have to put them exactly like this. So first we're going to write the last coefficient, which is, this one is the first, the second, the third, and the fourth. So first the 21. And then we're going to leave the second and the third in the same place. So 21 minus 3 and 6. And that we're going to do with all of them. So the last one, which is minus 49. And then we're going to keep it in the same place. Then the last one, minus 22, minus 9, and minus 4. And with brackets as well. And the same thing that we did, like writing the first two coefficients as we wrote before. So 21 minus 3, minus 49 and 1, minus 22 minus 9. And then do the same thing, multiply these minus the multiplication of this. So it will be 21 times 1 times minus 4 plus minus 3 minus 6 minus 22 plus 6 minus 49 minus 9. Then once we finish the red ones, we're going to add the minus sign and keep going with the blue ones. So 22 minus 22, sorry, and then 1, and then 6 plus minus 9 times minus 6 times minus 21. This is really time consuming, but it's quite easy once you get the hang of it. Okay, so now, like I said, keeping in mind all the signs and all that, you can do it like in paper, in like a calculator or whatever you want. So this is 2,166 minus 414. This is equal to 1,752. So the answer is 1,752. 152. Now for CY, the order of the coefficients will change once again. So first we have to keep the first coefficient the same, so the 2, the 8, and the 5. Here the 2, the 8, and the 5. So it will be 2, the 8, the 5. Then the fourth coefficient, which is the 21, the 21, the minus 49, and the minus 22. 21 minus 21 minus 49 minus 22, and keeping the third one the same. So 6 minus 6 and minus 4. Brackets remember that. Then the first two coefficients that you wrote, put them on your right. Multiply diagonally, first the red ones, then subtract with the blue ones, and the same process once again. So it will be 2 minus 49 times this plus 21 minus 6, 5 plus 6 times 8 times minus 22. Yes, that's correct. And then we're going to subtract it by the blue ones. So 5 minus 49, 6 plus minus 22 minus 6 and 2 plus minus 4, 8 and 21. So all this will give you changes the sign, 584. So CY is equal to 184. So now we're almost done. To calculate dx, we're done with this one, Now we're missing dc, sorry. So to calculate dc, the order will change of the coefficients once again. So first we're going to write the two coefficients. So 2 minus 3, these two. So 2 minus 3, then 8 and 1 and 5 and minus 9. And then we're going to write the fourth one, which is this one, these ones. So 21 minus 49 and minus 22. Keeping with the brackets, adding the first two on your right, the ones that you wrote before, and then multiply diagonally with the subtraction of these ones, and once again the same procedure. So it's 2, 1 minus 22 plus minus 3 minus 49 minus 5 plus 21, 8 and minus 9. So once we're done with all the reds, you add the subtraction sign and you go with the blue ones. So 121 plus minus 9 minus 49 minus 49, 2 plus the last row minus 22, 8 and minus 3, which is equal to minus 821 minus 1515, which is equal to minus 2336. So DC will equal to minus 2336. So now, once we're done with that, we still need to calculate x, y, and z. So right now, I'm going to write the formulas. So it's bx divided by a, y is equal to cy divided by a. All are divided by a, and then dc divided by a. So now let's substitute. So x is equal to bx. Your bx is 1752 divided by your a, which is minus 584. So x is equal to minus 3. Next, y is equal to cy, which is 584 divided by minus 584, which is my a. Y is equal to minus 1. Now c is equal to dc, which is minus 2,336 divided by minus 584. C is equal to 4. So now we have what we needed to get. And this is your answer and your whole procedure.
We will now introduce you to partial fractions.
What is the partial fraction decomposition method? The partial fraction decomposition is a method used to break down a complex rational expression into simpler fractions. This process is the reverse of adding rational expressions. By decomposing a rational expression into partial fractions, the problem becomes easier to solve, reducing complexity and making the process more efficient. The partial fraction decomposition only works for the proper rational expression, which is the degree of the numerator is less than the degree of the denominator. And here you have an example.
These are some of the formulas for decomposing partial fractions, but for the example that I will provide you, we will just use one. This is my example for partial fractions. The equation is this: 3x plus 29 divided by x squared minus 4 minus 21. The first step is to rationalize the denominator if possible. So in this case, it is possible. So I leave the numerator the same, 3x plus 29, and the denominator I leave it like x minus 7 times x plus 3. And I know this is true because if I multiply using FOIL the denominator, I get 2x, because x plus times x is x squared, x times 3 is 3x, minus 7 times x is minus 7x, and minus 7 times 3 is minus 21. If I simplify this, I get x squared minus 4x minus 21. And it is the same as my denominator, so I know it's true. Now, second step is to use the first formula of the chart I showed before this. So the formula that we're going to use is a divided by the first of the denominators, and it is x minus 7 plus b divided by the other one, that is x plus 3. So now to get the answer of this, I cross multiply the fractions. So this times this and this times this. It's called the butterfly method. So I get 5 times x plus 3 plus b times x minus 7. And the denominators are still the same. X minus 7 times x plus 3. Now I simplify the denominator, and it is 5x plus 3a plus bx minus 7b. I leave the denominator the same and I continue. Step number 5 is to join the terms with the same variable and get the common factor. So I can move the numerator so that I get the common factor closer. So I just move the bx a bit closer to the ax. So it's ax plus bx plus 3a minus 7b. And it's still the same, but I just changed the b of place. And now to get the common factor, I know that my common factor in this part is x. So I get x times a plus b, and I leave the rest the same, plus 3a minus 7b. And now I put the denominator the same. Now I know that this initial equation, which was 3x plus 29 divided by x minus 7 times x plus 3 equals the same as this one. They are now equalized. Next, since I know that seeing the denominator 3x, this one and this one, the things that are inside these parentheses are like these three are right here. So I equalize it by making the 3x equals a plus b times x. So it's like a plus b equals 3. So I now put like a plus b equals 3. And for the other one, I know that 29 equals the same as this, 3a minus 7b. So I put it right here. 29 equals 3a minus 7b, and it stays the same. Now for step number 7, we now have a system of linear equations, and we can solve it by using any method. In this case, I will be using the substitution method that I explained earlier. So I have a plus b equals 3, and now to get rid of the b, I pass it to the other side. So a equals 3 minus b. We now substitute the value of a in the first equation and simplify. I substitute the a in this equation. So now I go and I say 3, and the value of a is 3 minus b, so I put it right here, minus 7b equals 25, and I begin to simplify. I know 3 times 3 is 9, 3 times minus b is minus 3b, and I leave the rest the same. I now join these two like terms. I'll leave it like 9 minus 10b equals 29. I pass the 9 to the other side, subtracting, and I get minus 10b equals 20. And now to isolate b, I pass the minus 10 to the other side dividing, because here it's multiplying. So 20 divided by minus 10, now my b equals minus 2. Now we find a by substituting the value of b in the equation. My equation here was a equals 3 minus b. So to get a, I just substitute the b for minus 2. So a equals 3 minus 2. And I know that these two negative signs as like adding, so 3 times 2, and I know that a equals 5. And that's how I get my two answers. I know that a equals 5 and that b equals minus 2. This is all for today's video. I hope it helped for you to understand more these topics. Thanks for watching.